Hi, in this video I'm going to talk about hypothesis test for the population mean when you know the population standard deviation, and I'm going to use the p-value approach. So the p-value approach has the first step of developing the null and alternative, determine if it's lower, upper, to tail, specify the level of significance. You don't have to do anything with the level of significance alpha this time. Collect the sample data and compute the value of the test statistic. Find the probability of the z you found in this step. Now I'm gonna show you if it's a lower tail, you're gonna use this formula. If it is upper tail, you're gonna use this formula. If it's two tail, you find the p-value in this lower tail and in this upper tail. Choose the smallest value and multiply by 2. Compare the value found on test step 5 with the level of significance you have here. Okay. So let me show you how to do that with one example, the same example we had for the hilltop problem. I'm gonna do by hand, and later I'm gonna show you how to do in Excel. So I'm gonna show you both ways, and then you can use the one that you prefer. So let me go back here. So okay, we have let's start step number 1, the null, which is the mean is higher or equal than to 3. The alternative, the null and alternative, the mean is smaller than 3. Now I can look to see which tail I'm talking about. I'm talking about the upper tail because I want to test if the mean is higher. Okay. Step number 3 is find the alpha level. The alpha is 0.01. We know that from the problem. My one is so bad. I used to do a 1. Let me show you like this. But some students were confused with the 7, so I started doing like this. Okay, so we have these 3 steps. So the 4th step, I don't remember. Let me take a look. 4th step, p-value approach is collect the sample data and compute the z. So this is the same as we did before. Is 2.92. I see how different my sample is from the hypothesized. Okay, so I'm taking the difference and considering the variability is 0.18 divided by the square root of 36. This is equal to negative 2.92. Okay. Okay, there's one mistake here. This is a lower tail test. Why? I got confused because it has to be smaller. Smaller is this side. Okay, so is this is the reason it's always good to draw and compare with the hypothesis to make sense and to see if it is really in the correct way. Okay, so we have negative 2.92. We know that this is in the lower side. Now what I have to do is turn this this z value I found here into a probability. Then I have to follow this rule. Is it a lower tail? Is it an upper tail? Is it a two tail? Is it a lower tail? So if it's a lower tail, I'm going to use Excel like this. Let me show you in an Excel file. Okay, so let me delete this. So my z is negative 2.92. So what's the probability? So the probability for that c is going to be equal to norm.s dist, dist, and then I can type or select the cell that has the z-score and type comma and type 1, and this is the probability, 0.00175. So step 5, probability for the z equal to 292 is 0.001. Okay, let's leave like this. Okay, and the last step is compare the p-value with the level of significance. If the p-value is smaller than the level of significance, reject null hypothesis. Let's go back here. So this is, let's call this, to make it easier, p-value. P-value. Okay. P-value is 0.001. The question is, for step 6, is this guy smaller than this guy? Yes, it is smaller. So I reject the null and conclude the mean is higher. Is higher, no, is less, I'm sorry. This is less. Is less than 3. Let's wait. Less than 3. Because let's wait. The p-value is smaller than 0.01. Okay, so this is how you do by hand. It's done, it's solved. You reject the null, you conclude that the mean is small than 3. Okay, so let me see if there's something else in the slides. P-value stands for the probability value of the z you found, the z statistic you found. Okay, it is the p-value for the difference between the sample mean and the hypothesized mean. As we have in this is comparing the sample with the hypothesis. Is it too different? If the difference is big, and if it is big after considering the variability in the sample, then, and if you turn this into a probability and the probability of occurring is too small, then we have evidence that, we have evidence that this sample comes from a population that have a different distribution. Remember I showed you in the other video. If the mean in this sample is 3 and I get, it's not good to do it here because it's too small. Let me do it again. Okay, so let's say, let me wait. Every time I have to erase it, gets slow. Okay, so the claim is the distribution of cans has a mean, has a mean of 3. Has a mean of 3. If I have 292 and this 292 is too small for this distribution here, it's very unlikely that it comes from this distribution. It's more likely to come from this blue distribution, which means that all cans are being fulfilled with 2.92 ounces and not with 3 ounces. That's what is happening in all this test. Okay. And then we have some suggestions for interpreting the probability values. If it's less than 0.01, we have overwhelming evidence to conclude that the alternative hypothesis is true. Between 0.01 and 0.05, we have strong evidence. Between 0.05 and 0.1, weak evidence, and greater than 0.1 is insufficient to conclude that the alternative hypothesis is true. Okay, I'm gonna stop here, and in the next videos, I'm going to show you how to solve the same problem using Excel And another problem, uh, for the two-tail test, there will be two different videos using Excel to solve these problems, okay?